Now we are going to see the experiment 8, laser diffraction. Laser diffraction. Aim: to determine the wavelength of a laser light by the laser diffraction. Apparatus: semiconductor laser, screen, grating element and meter scale. The formula is lambda wavelength is equal to 2 into small d by m into xm divided by xm square plus capital D whole square under root. Here small d is nothing but a grating constant which is given as 2.54 into 10 to the power of minus 5 meters. And capital D is the distance between the grating and the screen. In this case we are seeing capital D we are keeping as 1 meter or 100 centimeters. And xm is the distance of mth bright spot from the zeroth spot or the central spot. The diffraction grating particulars are: the grating element what we are using here is number of lines per inch, which we are taken as 1000 lines per inch. Converted into meters, you are getting the value of D as 2.54 into 10 to the power of minus 5 meters. Now this is a diagram and experimental setup. Here the source is a laser source, a grating element, a screen and a meter scale, and the arrangement is as shown in the diagram. Here a laser source what we are using is a semiconductor laser which is giving a laser light. We know that the characteristics of the laser are highly coherent, monochromatic, high intense, highly focused and less divergent. Now we are using this source as a coherent source of light. The light is allowed to fall on the screen, and during its path a grating element having a grating constant is being kept in the path of the laser source so that the diffraction takes place and the diffraction pattern is obtained on the screen with the diffraction spots. Then that is diffraction pattern you are able to see on the screen. The distance of the grating to the screen is taken as capital D. Now if you remove the grating element, you get a central spot which is of laser light, central bright spot. But if you place a grating element in the path of a light, you are able to see the diffraction pattern which you can observe on the screen. This pattern is called as a diffraction, and in the diffraction pattern the intensity of the spots keeps on reduces. Diffraction is nothing but splitting of light near an obstacle. So this condition is been satisfied when the grating element is been placed in the path of a laser light. You can see the diffraction pattern observed on the screen. Now the central spot will be the bright spot, and left side and right side you can see the spots of decreasing intensity. This is because of the grating element. That means the distance between the two slits is comparable with the wavelength of the source. Therefore the diffraction is been taking place and you are able to see the spots on the screen with the decreasing intensity. The procedure: the diffracted beam from the grating is collected on the screen. The spectrum in the form of dots is displayed on the screen placed as shown in the figure. It is observed that the decrease in the intensity of spots as one moves from the zeroth order. Let xm be the distance of the order from the zeroth order. The wavelength of the laser is obtained from the equation. For the grating element, number of lines per inch are 1000. Now we can tabulate the readings taking the spots. Here first column is M, it is order, that is from the central bright spot, the first towards the right hand side and first towards the left hand side. The order becomes M, xm in L, that is the distance from the center spot towards the left side. First order is taken as L in centimeters, and R, next column R, xm in R means towards right side, that is right side first order, the distance from the zeroth spot to the first order towards right and left side. Take the average of left and right side, you get the mean xm which is converted into meters. So mean value of xm is being taken and calculated in this tabular column, and getting the values over here, calculate the value of lambda. For substituting the values of m, order. D is the diffraction grating element and xm is the corresponding distance from the center spot, which is measured in meters. You can substitute the value, and capital D we are using as 100 centimeters or 1 meter, which is taken over here. Calculate the value of lambda here. Similarly, go for the second order towards right and left. For the second order, m becomes 2. Similarly, for the third order, m becomes 3. Measure the distance from the center spot to the third order, corresponding left and right readings. Get the average, substitute the value of all these things in the lambda and get the value of lambda in the last column. So, number of spots you have got for both the sides, you can take the values, tabulate the readings, calculate the value of lambda and get the average wavelength is in dash nanometers. Now, the wavelength of the laser light is dash nanometers. Here we have used nanometers because it is a wavelength of the laser light. So, using the phenomena or using the semiconductor laser by the diffraction pattern, you are going to determine the wavelength of a laser light by the diffraction grating, and you have determined the wavelength of a given laser light in dash nanometers. For demonstration of the experiment, click the below link. It will take you to the YouTube channel where you can see the live demonstration of the experiment. Thank you.